Or the computer. All right, so welcome to our lab number. We got lab number 9. All your feedback will be on the video, then you'll be sad because you can't hear me. But so what we're gonna do is we're gonna program with Mastercam, and I have a full PowerPoint on this for you. So, but this video is gonna basically supplement that. Sound good? So go off the values in the video, not the PowerPoint, because I do everything on the fly, and they usually change here or there. That's not to say the PowerPoint basically numbers won't work, but not going to guarantee they're the same. Now, once you have your part for planning here, let's do this together as a class in a sense. You've learned about the different types of tool paths, or the basics of the different types of tool paths. What do we need to do in order to make this part? You could also look at your handout I just gave you. But what do we need to do? First, what do we usually do on the lathe first? Based upon the front of the part, right, to qualify the datum. So we're going to qualify the part by facing it first. It's going to kind of set up our Z0. Then after that, we're going to rough turn. And if you look at this part, let me get the zoom controls out of the way. If you look at this part, there's 2 different sections to it. We're going to rough it, but we can't undercut right here with our bigger roughing tool. Why not? Right, so the back of the roughing tool would crash into back here when it tried to dive down because of how fat it is, let's say, or the geometry, the angle. So we're going to grab a V and a D and then rough this area as well. So if you look at kind of the order of operations, we're going to rough outside profile, then we're going to rough turn the radius profile with a secondary tool. You see how that's tool 2? So that's going to be a V and MG, a little bit sharper tool. Then after that, we're ready to finish. We're going to then finish the front profile and then maybe finish the rear. I'm going to show you how to finish it all in one with a little extra geometry as well. So those 2 finished tool paths might turn into 1 finished tool path. Cool. The PowerPoint has it as 2. I'm going to show it to you as 1 in the video. They both will make the same part. Which one's faster? 1. So now after that, we're going to create the grooves. Sound good? And then we'll go ahead and then part it off from the bar stock. So to do that, let's go into Mastercam. In fact, I'm not gonna come back to this PowerPoint whatsoever. It's gonna be too confusing with the video. So let's go to Mastercam. What is the first thing we've got to do? Import our part, right? Or open it up. So I'm going to go File, Open, and then Computer. I don't think I need to talk through this part. Browse. Maybe I do. Then we'll hit SolidWorks files here, right? For the file type. And we'll go find where we saved our part. Can't do this if you didn't do your homework already, right? So is it week 8? No, week 9. Perfect. We're technically in we're doing Memorial Day lab right now. You realize that? Cool. So when we press open, so when you're enjoying yourself Monday, you're like, oh, I already got lab done. Good. So here's our part. If you hit F9, you can kind of see the axes are on and off. Is that a good place for a 0 point in our part back there? No. In fact, we might not even have, in fact, if you look at the world down here, you see it down here, we're all mixed up in terms of aligning our Z-axis up with the center line of the part. So there's a tool to do it very easily, or you could sit there and transform things like you did on the first project. What do we want to do? Tool. So over here, up on, where is it? Model prep. We're prepping our model now. And I'm going to basically, you see right here, it says align to Z. Everybody see that? So it aligns a solid body used for turning. What are we doing? We're using that solid body to make a turning tool path. So we're going to hit align to Z with that. What that does is I'm going to call it not custom WCS. I'm going to call it G54 WCS. Sound good? It's still going to be our G54 because we're going to shift the tools with it. Now, if I move right down there, what did I click on? The front circle right there. Why did I click on that front circle? That's where 0, 0 is. Does that make sense? Where Z0 is and X0 is. Does everybody see how I kicked the Z and the X out right there for me? You good to go? You see how I made a new coordinate system too with the F9 on? Yes.
Could you also do our like standard new coordinate system in the planes?
You could do it in the planes if it's lined up though. Oh yeah. So you have to have it lined up in the Z. You have to have the one lined up in the Z in the planes.
Yeah.
Yeah.
It's like the right.
Right. Yeah. Yes. And if you mess it up, we can shift it over later. Sound good? Kind of like if you mess it up in the mill. I helped someone this morning. It's like a button click. You just transfer to a different plane. So you just got to know where the button is. It's hidden. It's like a way back menu. So when we hit check mark, we created basically a coordinate system. Now, do you see the green is up in the front? Now, let me go to my planes. When I have that coordinate system. There's also this coordinate system right here. It's called D positive, Z positive. You see that? There's two ways to do it. I'm going to show you the second way now. Ready for that? D positive, Z positive is right here. The problem with it is you might have to move it around. So I'm onto a second topic. Does that make sense? So this D positive, Z positive, if I was to go C and T right there, check this out. And I go to, I'm just trying to show you this, how to figure it out. But when I go to home and analyze entity, when I pick right there, you're going to see my D is 0, my Z is 0. Press check mark. When I come over here, analyze entity, my D is 0, my Z is 3.75. So it's on the back of my part, right? I would have to shift it. Does that make sense? I'd have to now shift it where? 3.75 up, right? So I can literally, I think it's along the X though, looking at it. So it's easier just to do that though. So that's the other way to do it. I'd probably just do it the D positive, Z positive way, right? Now the second, that was easy too. You pick. But what you need basically is a coordinate system set up for the lathe with the Z and the X, or the Z and the D. Yes. You want me to show you that again? Let me delete it. Cool. So check this out. These are lathe coordinate systems. There's two ways to program a lathe, in diameter and radius. D stands for, X is for radius. Fair enough. All Haas lathes are diameter, so you'd only pick a DZ just for any Haas lathe. If I picked D positive, it's the direction it's clicking it on. So when I pick D positive, Z positive, I come down there, it basically sets up. Don't worry about X, Y, and Z. It's weird. It messes with you, doesn't it? Because that's the world coordinate system, but it's setting up to where when I go like this, my values, analyze entity, are 0, 0 for the D and the Z. We don't care about Y, by the way. Y is meaningless for us. So when I come over here, analyze entity, we're at 3.75. So we're literally just in front of where we need to be. So what I did, Grace, is I went ahead and I shifted it up to the front by just clicking that button. There we go. I could have just put the 375 in the X. And this is all based off the world right there. Yes. That's the world. I just proved to you how I know that it's not, because I'm in this construction system. That's why it's confusing. Yeah. Yeah, exactly. We don't care about the Y today. So now, I'm going to use D positive, Z positive. I recommend just doing that one. That's the easiest way. Align Z and then D positive, Z positive. If you do it in that order, you can't go wrong. because it'll have aligned it already, and then your D positive, Z positive is already set up where it needs to be. Yes.
Wait, so you can't just do.
You need a D positive, Z positive. Yes.
Okay.
You don't have to do the align to Z if you want to just transfer everything around. I think I probably confused you on that. Because I said now this is the second way, and that's what confused you, I think. Sorry. Yeah. We're good now, right? So let's go back to the PowerPoint just to prove. So we got a lathe diameter coordinate system. You need D positive, Z positive. Just how you align it. The align to Z helps you align it very easily at first. So now we need geometry, don't we? I hate to break it to you, but all lathe, 2D lathe is programmed with 2D wireframe. Oh, geez. We can't use this solid model other than to create the wireframe. So what should we probably do with our levels if we're going to create some external geometry? Let's just create a wireframe level for wireframe programming. So we'll go over here, we'll call it 2. And we'll call this wireframe geometry. Just geo works for me. So now check mark it, make sure it's checked. So we're creating geometry on it. And if you go to, if we're going to create wireframe geometry, which menu should we go to? Yeah, wireframe. If we're going to make a profile for turning, which tool should we use? How about turn profile? Sound good? So close. That was that's for mill. You're 100% right for mill. For lathe, what it does, do you know how a revolve works in SolidWorks? You draw half the profile and it basically spins it. This does the reverse. This takes your solid and makes the revolve profile, because that's all we really need. So check this out. When we hit turn profile, you're going to spin it, not slice it. It'll do a slice like for 3D printing. Slices it wherever you want it. But so we'll spin it, right? So it's going to spin around an axis, and it's going to spin around the Z axis, I believe. Remember we were practicing programming last class? Do we use the upper profile or the lower profile of the program?
Lower.
Upper. So we're going to select upper profile. Lower would be negative X's in the axis, right? Upper profile is positive X's. Make sense? So we're going to pick upper profile. We're going to drag a box around our part and hit in selection and check mark it. Boop. Do you see it there? So how do I get rid of the solid model? No, don't delete it. You hide it in your levels. So we only have this wireframe right here. Doing good? Cool. So that's the CAD part of it. Oh, we forgot to add virtual stock, but that's literally the CAD part. Setting up your model, getting your geometry going based off your coordinate system. Now to check yourself, actually one thing, I'm going to press F9. I want everybody to delete that so you can accidentally pick the bottom of the line instead of the top of the line and plunge down to 0 instead of the top of it. You don't need that line deleted. Sound good? It's going to make for beginners, let's just keep it off there just in case. When you go to part off, if you pick it's based off the midpoint. If you pick below the midpoint of that line, it's going to go to 0 first. If you pick above the midpoint, it goes to the major diameter. So let's just take that off and pick the edge on the top. So we'll be good for parting off. Now, have I confused anybody? We doing good? I got a nice shadow video with the sun coming in with my face, but oh well. Maybe. We'll get Delilah on a bicycle instead like that. So if we take the video off, I'll do that. So at this point, we need to go ahead and add virtual stock. Is everybody good with that? Do you remember how to add stock? It's under tool paths. What do we need before we add stock? A machine. So we're going to go to machine. We're not going to pick mill this time. We're going to go to lathe. We're going to manage list. And we're not going to use which one? The MM. We're going to use just the default. We're going to hit add. We're going to check mark that. Now I can pick that post. Within that post, we have the stock setup right here. So we're going to select on stock setup. I did. It's a little slow. So the way it works is what side's our spindle on? Left or right? Left. We don't have the sub spindle option, but if you had the sub spindle to transfer, you could do that. Now, what side are our chuck jaws on? Left, because it matches the spindle, right? So we're gonna show it jaws and we're gonna show it stock. So we don't crash into the jaws. Probably a good idea, right? So when I hit properties, it's kind of old Mastercam the way this works. This isn't the new stock menu. This is the old one. They haven't upgraded to lathe yet. That'll probably be in 2024. So at this point, what's the diameter? 1.5, right? How long was it? I want you to do 6. The reason is we're going to have the stock inside the chuck jaws too. Fair enough. It looks funny if you just did 4.25 and then put the chuck jaws right at 4.25 stick out because you're not holding on to anything. It's virtual, but it looks funny. Make sense? So now, what's the position along the z-axis? Ooh, maybe. It should not be 0. Is it negative though? Positive. You know why? We touch all the tools off on the stock. What do we do at G54? We shift it in 25 thou to Z0. So this right here would be the value you put into the opposite value of what you put into G54. Because it pushes the stock out, we push the tools in with G54. Making sense? Yeah. Yeah, I think that's what we put in our G54 yesterday, or when we set it up, whatever day we did that, Monday. Is everybody okay with this? Cool. So when I hit check mark on that one, notice it set up some geometry down there. You see it? Or some stock, some gray stock. It's looking good so far. But I want to show the chuck jaws to make sure we don't hit it with a part off tool or something like that. It's probably a good idea. So when I hit chuck jaws, these are really easy. It's like Legos. So check this out. You can build your chuck jaws with steps. What if you have more steps? You press add a step. What if you have left steps? You subtract a step. You got it? So you're basically building blocks because that's what the chuck jaws look like when they're spinning. You could actually bring in a model for pie jaws. You can make whatever you want if you have a fixture, but standard jaws are usually like that. So what we're going to do is we're going to go to parameters, the next page. We're not going to build them at all in terms of size. We're going to use the default size. I just don't want to run into them at all. So we're just going to put them where they're at. So we don't have to worry about getting around them. Now, the diameter, what diameter do they open up to? 1.5, because that's our bar stock size. Where are they at in the Z? Remember our gauge that Patrick made? 4 1/4. So negative 4.25. Check mark. Check mark. Oh, look at that. We got chuck jaws. We got a part. And then we can even shade it. Whoa. This is next level 2D. Look at this. So, this is a lot what it was like back in my day, just 2D shade, stuff like that. So they haven't changed lathe very much. So at this point, are you good with stock? We're ready to make some tool paths in, right? Told you this was easy. I left the easy project for the last, since you're all stressed out about your other classes, your 450 stuff and whatnot. So. All right, so are we ready to do some tool paths? Everybody ready to do this? Cool. So check out these tool paths. They're a little bit different. They're turning tool paths. Why is milling still there? Oh, if we had a live tooling lathe, we could do milling. We'll do a demo on that. I'll show you my cup holder. It's a really expensive one. It's not a real cup holder. That's what I call it, though. I can't tell you what it is, but it's a part. You'll see it's a live tooling lathe part. So we'll make that next week sometime in Mastercam. Sound good? Yeah. So now back to turning. Everything you're going to do is in general. What's C-axis? That's live tooling, only C-axis. That's not milling for Y-axis. That's only if you have a C-axis lathe. We're not worried about that because we're not in 336 yet. So we're going to go right here. And really on the lathe, you can't do much. You can rough, you can finish, you can drill, okay? You can face, okay, we got that. You can part off or cut off. We're gonna use that one. You can groove. They have a dynamic rough. We don't have the tools for it. It's sweet. But that's like on Inconel, big depths of cut. Look up some videos on it. It's really cool. I've never done it. Oh, I've done it on the one part I'm going to show you, but I've never done it for classes or anything like that. It's too much, too stressful. Remember, I don't like stress. So now this next one, thread, it generates a G76 can cycle line. Then they have a plunge turn for if you have a round insert. It'll go ahead and go back and forth and plunge in deep pockets. Then there's a contour kind of rough. It'll rough around the contour. So it's like it does a bunch of finishing passes instead of just straight roughing. I feel roughing's faster. And then they have custom thread. So after that, there's really can cycles. These generate the G76. Remember the roughing and the G71, the finishing cycle? That'll generate those can cycles for you instead if you want less code. So that's really, we're going to learn them pretty much most of them. So the first one we're going to pick is face. With face, it brings up a classic Mastercam menu. I've seen this since like 1998, this menu. Literally, you see how it looks old school too? It looks like Windows 98. It does, doesn't it? So that was a great software when it came out, Windows 98 compared to 3.1. So anyways, now, really? Yeah. So great. So now that's good though. So now, what's the difference between rough right and OD rough left? We had some different types of tools. I'm going to write on the board, those of you watching the video. What do we got? So we got OD, we got IB. So we basically have left, got right, and then same thing here. Fair enough? So these tools are set up right here. The way it holds. Let's look at it real quick. You see how we have that when they're sideways, they're going to be boring bars. So they go inside diameter when they're sideways because they go into the hole. When they're up this way in this orientation, they're turning tools. Now you don't want to pick any of the left ones. They have a bunch of them built for you right here. What do you think you could do? You can build one from scratch if you wanted to. You can build all your tools from scratch. I like to just grab the ones that they have that are very close and modify. So it's up to you. I'm going to just grab ones that are close and modify them. You can write down the numbers so you know which ones to grab too. And whatnot. So if you think about it, what's the most popular turning tool out there that I told you? CNMG 432, right? Or CNMG. What do you think tool one is? Let's double click on it. This sets up your tool. Oh, look at that, a CNMG 432. So number one is the most popular tool. We're going to use that one. Sound good? So their tool number one is our tool number 101 if you weren't here the other day, right? But it's really T0101. Even know. Okay. So we might have got somebody, who knows? So this is even better. Check out these catalogs. They got catalogs from all the different manufacturers in here. You know why? They're all standard shapes and sizes. So when I go to I'm probably going to pick one that doesn't have any stuff in it. So Sandvik. I can get insert. Oh, wow. They had all the interns put these in. Do you think they paid the engineer to put this in? No. But check this out. So so if you had your exact Sandvik insert grade and everything, check that out. You're ready to roll. You know what? It's even better. Sandvik bought Mastercam last year or 2 years or so. I have a feeling they're going to be able to just order the tool right here. Like, come on now. Like the plugin where if you just do all your programming, order me my inserts and they show up. Come on. I would do that in a second. I think that's where it's going. That's where it should go.
Like you could export a cart.
That's all these are. This is their catalog, right? This is their current catalog. So if I wanted to, what matters? Hold on. CNMG 432. See how there's a bunch of them? It honestly doesn't matter as long as you have the right shape and size for right now. We're going to change the feeds and speeds. So if I hit check mark for that one, it actually would have the feeds and speeds set up for it for that insert. That's kind of cool to kind of start, but we're going to just go to general turning, insert. We're going to build a 432. I'm just going to delete that actually. And what matters actually, if you think about it. So a C, 80 degree, you see that? So in, here's your relief angle. You see that 0 degree. M is going to be the insert's tolerance. We're not worried about that, right? Because it doesn't have a tolerance in a computer. Everything's perfect for it. So we're not worried about M, but we're worried about G, how it's mounted, maybe just to show on the simulation. Then the 4. What was that? 4 what? 4/8. 4/8, which is the half, right? There we go. And then we have the 32, so the 3/16 for the thickness. You see that? And then the 2/64, which is 1/32. So that's all that matters, is that you build the insert with the right geometry for the cutter comp. Cool. So the catalog's nice, the inserts are nice, but whatever. It'd be cool if I could order it. I guarantee it's going that way. So it's sometimes you got to. So especially if you own it and you own all these inserts and yeah. But anyway, so now back to holders. The holder we care about, but the holder is so generic you don't have to change it at all. The most generic holder is a 5-degree angle one. And that's what all of our holders are. They clock them off 5-degree rake angles. If you had something other than 5 degrees, what could you do? Change it and build it, right? We're good to go. Now, parameters here. This is where you're going to grab. Oh, you don't have any speed and feed data. So you're going to write this down as part of my demo. Tool number 1, we're going to run basically a 10 thou chip load, and we're not going to ever plunge. So we're going to run a 10 thou plunge. We plunge outside of our part. Plunge matters. If you saw those dynamic ones that plunge, that matters. We're not plunging like that. Now, what's inch per rev versus inch per minute? What G code covers that? 98 and 99 are the feed rate ones, but good. We're going to keep that answer for the next question. So the 97, 98 and 99, right? So 99 is inch per rev, 98 is inch per minute. What are we running when we're turning? Inch per rev. So we never change that unless we're doing like some drill, or so unless we're doing some bar pulling. That's what we're not doing. Now, what's this spindle speed right here? If I do 650, I have CSS and RPM. What's the difference in the G codes? 97 versus 96. 96 is CSS, 97 is constant RPM. What do we want to do when we're turning? Constant surface speed, right? We only do constant RPM, and we have a center tool like a drill or a reamer that has a known diameter that you calculate the RPM for. Cool. All right. So 650. Don't worry about the roughing and the finishing defaults. We're going to change those as we go through. So when I hit check mark, that builds my tool, everybody. Are you good to go? So it's tool number 1, offset number 1. We only have 1 station, so we'll keep that at 1. The post ignores stuff that doesn't matter. It's like it would ignore station. So there's different. So on the multiple spindle ones, you have 2 stations. Sometimes you have multiple turrets. 2 turrets, actually. The post is the post processor that when it creates the G&M code, it doesn't grab every little piece of data out of here, only the stuff it needs for the specific functions it does on the machine, or the parameters that it has on that machine. So we're good here. What's the max spindle speed on the tool room lathe?
2000.
Thank you. So 2000. We're going to still spindle speed clamp it. We're going to spindle speed clamp it at the max. Sound good? We're going to still put the number in so it's legit. So at this point, we go to face parameters. You know it's the easiest? Using the stock. You could actually hit select points with that button. You'd have to go select points or like a bounding box on where you'd want to face. That's a pain. Use your stock. You built stock for a reason. Sound good? Now, what I want to do is I want to leave 5 thou because this isn't the finish tool. So where this says stock to leave, we're going to leave just 5 thou. We're going to come around with the other tool and finish all in one. Sound good? But we're going to get rid of 20 thou and kind of qualify the stock. Make sure your pullout was decent. If it doesn't face anything, you didn't pull it out far enough. If it takes a huge cut, you really pulled it out way too far. Fair enough. You didn't use the gauge right. So when I hit check mark, watch what happens to the stock. Ooh, it got shorter by 20 thou. You see that? And you see the little tool path? This is good. If you want to hit the back plot window and you press play, there it is. It's coming in, right? Actually, it's more of a high-speed whine because the lathe's winding up at that point, right? Nope. Did that look good? Are you happy with that? I was happy. Cool. Got any questions, or you think you got this? Are you following along? A lot of you able to keep up? Oh, that's cool. You won't have homework. Only the people watching the Zoom video. So at this point, we've got roughing. Gotta have fun when you work. So when I rough this thing, we're gonna use the chain, but we're gonna use the partial chain. Sound good? We're not gonna chain the entire geometry. We're only gonna rough up to a certain point. Wonder why?
I wonder where.
Oh, I'm gonna show you. So check this out. When I'm roughing, do I want to come down here again right now? No, right? That'd be a waste of time. So I want to start here, green. I want to end. That's why we're doing partial. I want to end right there. Green, red, start, go, or start, stop. Now, when I hit check mark, am I using the same tool for this part? Yes. Not when we rough the radius in the back, but right now we're going to rough that whole part. So I don't have to build the tool again. I just use that one that's got the check mark with it. It means I've used it. I'm just double check that my feeds and speeds are good. I didn't set my max spindle speed in the tool information menu. So it's going to go to 10,000 every time. So go to 2,000, sorry. See how easy these menus are? Look at it. I love Lathe. Lathe is easy. You can make way more money programming a lathe than you can mill because you can bust them out quicker and charge more because you charge an hour no matter what. You're done in a half an hour. So it's like good to go. So at this point, does the auto mechanic charge you a half an hour? No. Pointing that out. So 0.05, right? Especially when they do it in 10 minutes. So book hours is a whole nother thing, but I have some friends at dealerships that make book hours. But that's a whole nother story. So back to this. 50 thou depth of cut. If you go anything more than 50 thou depth of cut, everybody look at me, you're going to stall the lathe. We're going to get really close to stalling it on purpose just to show you how to max the thing out. Sound good? Don't go more than that depth of cut. Cool. I'm going to push it on my demo to show you wind down and wind. It'll be cool. So at this point, we have a slight. Why would I want this exit amount? Let me change what I was going to say. We talked about this yesterday a little bit. What's that exit amount do, you think?
It extends the tool path just a little bit.
It extends the tool path a little bit. Why would I want to maybe do that? For the part off tool, remember we talked about that? How thick is that part off tool? 1/8 of an inch. If you look at your tool 4, it says 0.125 inch carbide part off tool. So there's a 25 thou chamfer on the back too. You see that we didn't really grab on the line right there. So let's add that chamfer and let's add the part off tool. Let's go 150 back farther. Cool. Good. So we put 0.150. Everybody good? So when I hit, let me show you something here. You see these plunge parameters? Do we want to do any type of plunge cutting? Not on this one, so no plunging allowed. If you pick this one, you'll crash the machine. We're going to pick this one on the next tool path. Sound good? But not on this one. So that allows you to plunge. You can kind of see what it does, right? In the graphic, it allows you to plunge into grooves. And this tool is the CNMG. It doesn't plunge. Only the VNMG plunges down. So we're going to hit check mark. I just want you to double check that and check mark. By default, it should be no plunging. Now, did I leave stock? I don't think I did. I think I forgot that part. So let me go back to rough parameters. And, oh yeah, stock to leave in the X and the Z10. I just wanted to double check that because I didn't put that value in. That must have been default. Yeah, makes sense. They left some stock in there by default. So 10th will be great. Go ahead. So cutter compensation, check this out. Computer control. So if I wanted to program on the lines, I would do control and it would post to G41 or 42 and to have the control deal with it. We're going to allow the computer to do it just based off the insert that we selected. Does that kind of answer your question?
I was just wondering like the difference between the right and the left.
Oh, it has to do with the side of the line that it's going to compensate. It'll post G41 or 42. So now we're on the right. So we would actually be on the right. See that? And it actually picked it right for us. So now when we hit check mark, it creates those toolpaths. And look what happened to our stock. It updated. Ooh, right? So when I look at it, you can kind of see it. Look at it. It cut on the geometry, but yet it left all that stock. You see that? Why is that again? Yeah, the theoretical tool tip, right? If you see, because the blue line is on the stock, but it left stock up there. See, that's what I was trying to get at. Yeah, so cool. Now, at this point, we're ready to go ahead and rough back here. We can't plunge with the CNMG, so we're going to switch tools, and we're going to go ahead and we're going to rough turn right over here, rough. So when I rough, I want you to rough from here to here. I don't want you just to rough the radius. Why do you think that is? It's smoother to go ahead and just come in from the outside and plunge down than just doing the radius. You never want to do just the theoretical exact and stop this theoretical exact boundaries. You want a little overlap. So it has to do with when you selected it. So I probably would just hit the unselect and reselect. And it has to do with where you, so like, check this out. You see how it's going the wrong way? Because I was past the midpoint. If I go back here, I select over here on the other side of the midpoint, it goes that way. It just has to do with where you select. I never really mentioned it. It's kind of like just do it in my head. So it's all based off the midpoint of the line. So when I hit check mark, what do I do now? Do I use that same tool? No, I'm going to go down and find, I'm going to find one that looks right. Ooh, is this VNMG? It's not 55 degrees. Let's keep going. There's a OD finish right 35 degree. What do you think? A V is a 35 degree. So let's double click on it. Check this out. VNMG. We doing good? Any questions? So what do we have to change here? Yeah. So just change that, right, Dominic? We're good? The one at the end of the name? Or did that do it?
No, yeah.
Corner radius right down here. Perfect. You were right. I was just having fun. So we got 1/32. Everybody agree? That makes that a 2 up here. This is just the label. That doesn't. Cool. So now under parameters, that's really weak. We are going to make that not 21. What are we going to make it? 2. We're not going to worry about holder. The holder's a 5 degree holder. I'm sure we can go check. Yep. Oh, it's a 3 degree holder. We're fine. I think we have a 5. Don't matter. Ooh. We could do that. It's not going to make a difference. It doesn't make a difference. So with parameters right here, it's tool 2. I want to run a 7th thou chip load with the thing. We're technically plunging, but not really. So we're going to run 7th thou. Now, the spindle speed is going to be 650 because it's carbide and aluminum. We're pretty much maxing out this lathe. That's why I'm only running 650. And they don't have a spindle speed clamp value in here, do they? You'd think they would if it shows up in the other menu. So I'm going to go ahead and press check mark. Moving over here, 7,650, 2,000 maximum spindle. My rough parameters now, this tool is very sharp. It doesn't take a big depth of cut. We're going to run a 25 thou depth of cut with it. I think the slides say 35. It'll do 35 too. Do 25. Now, when I go to my plunge parameters, what do I want to do here? Check this out. I'm going to do the second one. I want to go on both X and Z. If I only wanted to plunge on the diameter, it would do that, or only on the faces, it would do that. You see that? But we're going to plunge on both of them right there. So when I hit check mark, I also want to make sure my exit amount stayed at the 150 thou. This tool is going to exit as well. Yeah, we're leaving stock because we're roughing. We're going to come back and finish with this. So I guess it really didn't even need to exit 15 thou because it's not going to cut anything. Oh, well, it don't matter. Little air. So when I hit check mark, it's going to, oh, yeah. Just keep pressing check. I forgot one thing. This is bad. I forgot to, what did it do? In fact, let's fix it on it. Let's figure out how we're going to fix it. What did it say? Tool collision with stock on the lead in, didn't it? It didn't lead in right. Do you see how it's lead? Look, in fact, it let chunks when it let in. Do you see that? That's really what it would do too. Try it. So maybe not. We'll go to, you'll just have to run another one. So at this point, in order to get your credit, so we'll go to lead in and lead out. Right now, it's using something called the fixed user entry vector. It's entering at 180 degrees. Remember? So then the lead out is entering or exiting at 45. What we can do is we can go perpendicular to the surface. So it comes straight in perpendicular to the surface, cuts, and then doesn't gouge the surface. So it's coming in perpendicular to wherever that surface normal Z is. Does that make sense? I'm going to then exit perpendicular as well. Might as well. So when I hit check mark, I'm glad we did that. So I totally forgot about that. So look at that. It fixed it. And so do you see it leading in now? It's not going to gouge it with the back of the holder. Cool. Simulation worked. Yes.
Does leading in at that, like, it's sharper angle?
It's going to put a weird force on it, but it's a small depth of cut. It's not going to hurt it. Because, yes, you're right. See how this direction changed? Like it goes negative, it goes there, and it does like an acute angle when it does this direction change, which is normally not good. You want an obtuse one. So, but we're fine. This is what we can do to get this part done. Now, so if you look at that, we're fully roughed. In fact, I don't even simulate really because I look at the stock. You don't really need to do a simulation like you did on the mill part. You can, it's there. We'll do it at the end. But what do I have to do now? I have to finish. Now, to be honest with you, it's easier to do one toolpath and make geometry to make that one toolpath. What if I pick plunging and I pick all this geometry, what's it going to try to do? It's going to try to plunge these grooves, but then it's going to come up here and plunge this to finish that, which it needs that. So the PowerPoint has you make one pass up to that point, and then has it come back another finish pass right there. Kind of just, in order to do it in one, I need to basically have a level with some finish pass geometry. So I'm going to do that real quick. I think it's going to be better. So I'm going to go to level real quick. I'm going to make a 3. I'm going to call this finish wire. Sound good? So this finish wire is actually just going to get made with my original model. It's going to be the easiest way to do it, I think. And under wireframe, if I just do a turn profile again, all the settings should be there. I turned off everything. Let me turn on my toolpaths too. They're kind of. So under levels, you got your model. Now I got finished wireframe. What am I going to do here? I'm going to delete that. In fact, I'm going to drag a box over all that real quick. And that. And I'm literally just going to then draw a line. Make sense? Is everybody good? So that's my finish pass. What am I going to delete? I'm going to delete that thing. Don't need that. In fact, for my finish pass, I don't even need that little. Check this out. Technically, it doesn't have a chamfer here. I'm just going to show you some other tools because you don't need to do this at all. You can extend it. But it's got basically over here on wireframe underneath modify. Where's modify length? There it is. Modify length. I can lengthen it 25 thou. Now I can get rid of that chamfer and be at the right edge. End. Does that make sense? See how that works? Cool. I can press Control Z a couple of times. There you go. You ready? So it's modify length. I lengthened it 25 thou. And you got to pick on the right side of it. You pick there, it does that side. If you pick over there, it does that. See that? It's a midpoint thing. Control Z the one. Cool. And then delete that one. How we doing? Good? Cool. All right. So all that just to get a little finish pass geometry. So when I go back to my tool paths, I'm ready to now pick which tool path. I'm going to pick finish. And I'm going to finish from the bottom all the way up to there. I'm going to come around. I left 5 thou, right? Bless you. Now, when I hit check mark, is this tool changing? No. But this spindle speed clamp needs to go to 2000. How about on my finish parameters? Is there anything I need to do? I don't think so. I need to check the plunge parameters though, make sure that plunge is on. Other than that, you don't really have to do anything. Check mark. Are we leaving stock? Nope. So when we hit check mark here, see how it over and undercuts that? Look at that to make that radius. That's that theoretical tooltip, right? We learned about. Comes back here. Do you imagine trying to do the calc for this back here? That'd be a pain. I'd rather push a button. Do you have any questions on that? No? I need to now show my level for my grooves and turn off my finish wireframe because I'm ready to start grooving. Now, this is going to happen to like probably 3 or 4 of you. You're not going to listen here. This always perks your ears up a little bit, right? So when we go to groove, are we doing one groove? Or are we doing multiple chains? Jack, what do you think? Multiple grooves or one? So we should probably have multiple chains. What do you think? When you don't have multiple chains, you're going to turn the whole thing. You're going to have the hardest time making this tool path. Promise you. There's multiple grooves. There's multiple chains. So when I hit check mark now, what do you think it needs to see? Multiple chains. So I'm going to grab partial chain. It doesn't matter where you start, but you're going to want to zoom in. You're going to want to pick the chamfer too. So you got to zoom in really well because if you pick down here, you've already blown it. You got to pick right above it up here to right there. Why didn't I do it? There. Yeah, it does. It's on the notes. Chamfer all edges by 10 thou. gotta look at your notes. That's the first thing you look at your drawing is you look at your notes. Yeah, that's too bad. So you know what you can do in Mastercam? You know what you can do in the Mastercam? Hold on. I'm gonna X. Model prep. Where is it? You can remove all your fillets. Hold on. Give me a second. Hold on. Solids. They got a freaking chamfer tool. Where is it? Do you see it? That's it. I don't have anything to chamfer. I get, hold on, maybe I do. Hold on. I'm pretty sure it works. I'm pretty sure you can throw the chamfer on the model right there. If not, what could you do? Go to your SolidWorks, chamfer it, merge it back in, and then just do another turn profile real quick to show that for the grooves only, and just have one for the grooves. Does that make sense? Oh, your wireframe chamfers. If you could just throw some chamfers on your wireframe, guaranteed. I could show you that right now. Hold on. There's more than one way to do everything, right? So check this out. If you had a sharp corner, I don't want to start deleting that, but if you have a sharp corner, the wireframe and this chamfer tool does it for you right here. So don't make your model have the chamfer on it. Just put it on the actual wireframe right there. 10 thou chamfers. Did I just solve your problem? Yeah, somewhat. Cool. All right, back to this. So in turning, we still got 20 minutes and we got this whole demo, I promise you. We're just about done. So I gave you an hour worth of homework. So at this point, we're going to go to groove. What's important to pick? Multiple chains. So we'll select multiple chains. We'll hit check mark. We're going to pick partial chain. I'm just going to start over here. There, two. There. You have to hit the in chain button. You see that? Then you go from there to, whoa. Rollerball mouse failed me on that one. You got locked in the. So, no, it don't matter for right now. We're going to groove to the center, so it don't matter. If you're grooving to one edge, it would matter because it would be your finish edge. But we're going to meet in the middle. Sounds like a deal. Bad joke, too. There you go. So when I hit check mark, it doesn't matter what type of grooving tool you have here in terms of right, center, or left. You know why? It's going to go in and groove. It matters for simulation. If you want to make it so it's perfect, we have a right-handed grooving tool. So we're going to grab a right-hand grooving tool. In fact, is ours 125? On this sheet, it says it is, but no, what's the grooving tool? 0.095. The sheet's got it right. So on this sheet, we're going to double click here. It's a grooving. The insert is not universal. So you build it right here. It's kind of a single end, like you see right there. What's the D value? 0.095, right? It has a 5 thou radius on the edge. C. B doesn't matter, and A is 0.125. They're both the same thickness. Is it going to let you do that? No, it won't let you. Just leave it at 0.93. Let it neck down. So when you go to your parameters now, is it tool 44? 3. Tool offset 3, tool station 3, tool back offset 3. So now we're going to run a 3 thou chip load with a thing, and we're going to plunge at 3 thou. We are going to run an RPM with the thing. When you start spinning them too fast to these grooving tools, they like to start to chatter. So we're just going to run 500 RPM. We're going to put a lot of oil on. You heard it kind of chatter on the Mario bullet, right? So when I hit check mark, this is the easiest toolpath. Groove shape. Do we want to groove in at 90 or any other angle? What do we talk about for roughing a groove on the in the beginning of the lecture last class? It showed a little insert and it showed you the directions on what we do. What way do we groove in? What way did it groove in the demo? Straight in. What degree is that? 90. Thank you. So in the groove roughing, it's going to come in 90. And we're going to leave 5 thou for the turning pass on the thing. In fact, I would probably only leave like 3 thou just so it cleans up. Barely takes off anything on the next pass. Now, it's going to be really bad if you rough it 75% the width of the cutter. So we're going to do 25%. Sound good? The first one's the full width, but after that, it's 25% of it. Back off is how much it backs off before it goes over. Like it's angle up. You can kind of see it there in the graphic.
The first plunge speed rate, you can change that to 3.
Let's leave that at 2. First plunge feed rate at 2 because it's a full width of cut. Then it can go to its 3. Now check this out. Groove finish parameters. We can groove multiple ways, right? So we are going to have a overlap between passes. I put like 10 thou. Just so it's not perfect slices. Sometimes you see lines if it's perfect slices. So you want a little bit of overlap. Does that make sense? But not much. So like 10 thou isn't very much. Now, its finish step over will be fine. There's one finish pass. Somewhere it's going to say groove to center. Anybody see that? Where is groove to center? Hold on. Roll around corner. They changed this. Bidirectional alternating. Hold on. That's the cut direction for roughing. I thought there was one for the... It doesn't really matter. Direction for first pass. Maybe it just grooves the center now no matter what. Oh well, we'll hit check mark. Looks good to me. Whoa, put grooves in it with some chamfers so it's not sharp. It's gonna be sharp otherwise. Anybody have any questions on that? No, so check this out. The way the toolpath looks, I still got 15 minutes. We're good. The toolpath comes in. Maybe go a little faster. Starts grooving, and then it... Why is there such a big gap on the one side? It's the insert's thickness, right? If you touch it off on the left to the part. Cool. So it roughs them all, and then it finishes them all right there. You can kind of see that. Good to go. So check mark that. What's left? This is an easy one for me to prove out. I kind of just look at lines. I'm like, all right, go have fun. So at this point, we're going to have to go ahead and part it off. I have to pick a point on the back. That's the part off point. I'm going to use my finish tool path, my finish wireframe. I'm going to turn that on so I can pick back there, not the bottom where the chamfer is. Does that make sense, everybody? And look at that. Our stock is right where our part ends, so we should be good to go. Maybe you can go back maybe a little farther. That doesn't really matter. But so when we pick cutoff, I pick right there because that's where I'm going to part off. Did you see it put a point right there? So the part off tool is kind of important. The thickness of it and the style of it. It's all the way at the bottom. See how it says cutoff tool? It's a right-hand one. So because it's not tool 151, we'll double click on it. That'd be a big turret on a lathe. They don't make them that big, guys. So when we have this insert, it's the most important part is this 1/8 inch right here, this E value. The rest is meaningless. We're not worried about that after that. For this. So the holder, we're not too worried about. What's important though on the holder for simulation? This C value right here is important. Why? You don't want it to crash into your part. C is 1.5. Are we going to be okay? Yeah, because it's a 3-inch diameter bar stock it could part off, right? So we only have 1.5 inch diameter bar stock. We're good to go. Just wanted to point that out though. So that's important. Stick out length of your part off tool. So now parameters here is we're gonna go to 4, I believe, right? We're gonna just let's just run a 2 thou chip load, not 2.5. And we're gonna run a constant RPM of 500. Sound good? That way it just drops into the rubber pad, hopefully. So we did, it dropped into the rubber pad on the Mario bullet. So should do that with you here. So when I hit check mark, I know it's set to 500. I just like to make sure the max spindle speed is just set to the RPM value, just because. I know it wouldn't go above 500, but it's nice to have that clamp just in case. So in the cutoff parameters here, it actually does a really poor job at making a chamfer, but we're going to try to do it. Sound good? So it does chamfer parameters 25 thou at 45. A little radius on it. It had 3 thou. We'll do 5 thou. It's because it kind of rolls into it. So yeah, it rolls in and out. Then what did I want you to do with the chamfer or the part off tool? So when I hit peck, I come over here. I want you to peck depth at 50 thou. Now, if you're pecking, do you think you should retract? Yes. What happens when you retract 10 thou absolute? Goes all the way to the center of the part. What should we probably change that to? Incremental. Be a way better day for you. Does that make sense? It's going to retract that. Otherwise, you could tell it to retract to an absolute X value every time. 10 thou absolute X would be a very bad day. So we're going to go ahead and do 10 thou incremental retracts. Does that make sense? Hope so. So when I hit check mark there, I hit check mark. It's going to probably say it crashes because that holder isn't really designed to go ahead and make a chamfer. It still works great. So now my stock's missing. Where did it go? Oh, I parted it off. So it's gone now at that point. So that's the process of programming the lathe. Now, to wrap things up on today's video here real quick, we're going to go to tool paths and we're going to simulate everything to make sure it looks good. So when I highlight the whole toolpath group here, it checks everything. And I'm going to go ahead and hit the verify now. You're used to this one. Probably should hit save too. We'll run this on Tuesday in lecture. And then we're going to get into maybe into the live tooling lathe programming, and the CMM should be ready to go then. So we'll probably run it in lecture. We'll probably do CMM and this in lecture, and then do a little bit of live tooling programming. Cool. So check this out now. We got our parts sticking out of the chuck. They're just dummy solids. That's all they are, just to represent basically where things are. That's all you need, right? It's just kind of a boundary of where you're going to hit. So if we wanted to make it look like the slant bed is back here, it's the tool room lathe that's like this, right? So that's all it is. That's all it is. So when I press, I'm going to slow it down. Oops. We're looking good. Bless you. Good old allergy season. It was bad for me this morning. Me too, but Not really. So we're roughing back there. It's looking good, right? Why hasn't it touched the top yet? Because we left stock there. I got it there. Now it's grooving. Oh, I had alternate on there. You see that? It's a waste of time. It's alternating sides. It's an extra time to move from this side to that side, right?
Why would you want to use that?
I don't know. There's that option though.
Is that in roughing?
Yeah, it's in roughing. They're alternating sides in roughing.
Doesn't matter if you can pause the computer first.
Doesn't matter. So in real life, rigidity, you'd start on the outside and work your way towards the center because you're more rigid that way, right? This isn't going to make a difference. There we go. Now it's parting off. And it's gone because it disappears. That's like kind of lame, that part. So it's like I can't even look at it anymore when it's done. Huh? You could ghost your parting and look at it. Yeah. So that's the process. Now, hold on. Let's look at, there's some things we got to do with the post. So I'm going to post here and show you just so you're kind of ready to go because I really want you to be up at that point. So we'll go there. We'll hit G1. There's nothing different here, right? So when we hit check mark, project 3, we're going to end up running that. So I'll put it in spring 335. We'll put it in week 9. We'll call it 337. Sound good? When I hit save, I'm going to replace whatever I did last year. That was actually in fall. And check this out now. You've done it right. Well, these are really long comments. I have a problem with file extensions, so that's really long. We'll delete that long comment. I want you to just call this 337. Sound good? Because that's what we're up to. So we'll call it 337. Put your name in it. Now, look at that. T101. We're doing good, right? No tool change. It's not supposed to. We learned about that. G18, we learned about that, right? G18 plane. So G97, it starts it up to 1400 RPM. I don't know where it gets this number at first, probably where the diameter is. And it rapids to the start point. Then it turns on the spindle speed clamp and then turns on G96. So it starts at always, this post starts at an RPM first. You don't have to do that, but it's the way it works. Then G99, all of our F values are our chip loads. I want you to verify all your X's are positive. Why is this the only negative X on the first pass? It's the face pass. It's got to go across center, the nose radius value, the nose diameter value. So it took the nose radius and doubled it. The 03 is a 06 now. So that's why you get that 1/8 of an inch right there. Does that make sense? So that's the only time you should see a negative X. All your other X's should be large, like 1.7 to come in, 1.5, and you should be getting smaller as you go down. right? So now there's 2 things you got to erase. Actually, it's only one thing, but I'm going to make you erase a bunch. What does U and W do for lathe? Incremental. So that should be fine. What's V? V is Y. This post sends the Y-axis home incrementally between every tool change. There's no Y-axis on this lathe. It just kind of does it just because it's kind of like a thing in the post. So all I really need to do is do the V, delete the V. I'm just going to have you just take the UVW out completely. I won't confuse you then. So we won't have any incremental in it. Sound good? So how many times does that happen? 4 times, because how many tools are there? 4. So that's at the end of every tool change. So I go look for the next tool change. Look at that, UVW, just take it out. Cool. Next tool change, I go down. This is the grooving. Lots of grooving, man. Look at that. There we go. UVW. Out. And then look at the PEC. Part off with PEC was easy, right? Just a bunch of X moves. That's all it's doing. Then UVW. I guarantee this will run. We're going to go run this. I'm going to press save now. We'll go run this on Tuesday. Have a great 3-day weekend. Have a great time. Seriously, it's like, enjoy yourself. So, yeah, I'm going to have a good time. Don't worry. So, we're going to go ahead and stop sharing. We're going to